or you may be placed on the government's most wanted list. So it's one or the other, or both. Yes. All right. So let's go ahead and take a look at, since we were talking about robots, battling robots. So we'll go and take a look. Most people know what are battle bots, right?
Yes.
You guys do remember battle bots from way before. They don't do that anymore, do they?
I haven't seen them in years.
It's out of fashion, at this point, because battle bots, for the most part, are remotely controlled robots. Okay, you actually have people or teams actually remotely controlling those robots. I think you need a team of two, one person to do the navigation and the other one to operate the weapons, so the robots can, duke it out and try to take each other out. And the arena itself, also has traps and all sorts of weapons too, like flamethrowers and big buzz saws and stuff like that. My favorite are the flippers. Have you guys seen the flippers in BattleBots? They're usually CO2 powered. The flipping mechanism is CO2 powered, using carbon dioxide. And the way they work is they're very flat. They try to get under another robot, and there's a mechanism to flip the other robot. And most robots are pretty big, and they're not designed to kind of right themselves up after they're flipped. So the flippers can basically disable the other robot without really destroying it, because most robots cannot flip themselves back up. The flippers by themselves can also flip themselves back up. So if a flipper is upside down, it would actuate the flipping mechanism and flip itself upside up, right side up again. So it's fun to watch two flippers trying to flip each other to death. You can look up YouTube, and they have videos of flipper battles, and it's just fun to watch. It's essentially boils down to who runs out of CO2 first. Okay, so it's about the efficiency and the effective use of CO2. The problem with CO2 is if you use the CO2 tank too quickly or too much, it freezes. Okay, people who play with a paintball know about that already, because if you discharge compressed air of any kind, it decreases the temperature. So once it gets to the freezing point, then no more CO2 can go to the air cylinder anymore, and so the flipping mechanism will basically stop working. So they got smart. They put the CO2 containers next to the motors, and the motors are the ones that are running hot and requires cooling to begin with. So now you are getting both the benefit of cooling and also warming up the CO2 at the same time. So it's kind of interesting. I'm not going to show you that because you already know about that. What I want to show you is Sumo bots. I think if I look up Sumo bot, there will be a lot of entries. And we can just go ahead and take a look at images. Okay, these are called Sumo bots, and in a sumo wrestling, how many people know what is an actual person-to-person type of sumo wrestling thing? Okay, so you have two big guys, basically, doing the ritual thing, and then, once they drop the flag, they try to push each other out of a ring. So it's not about who punches, which one, out first, or hurting. It has nothing to do with hurting. In fact, I think they have rules against, actual hurting the opponent. So the whole point is just to get the opponent out of the ring without a lot of really actual punching, kicking, or elbowing and stuff like that. So when you watch this, we can go to YouTube, and there are tons of clips of sumo wrestling robots. So let's pick one that's popular. And this is affordable. To put together a sumo bot, it's only about, I would say $30 or $40, depending on what type of motor, wheels, tires, and controller you want to use. But it's not expensive at all. From the ashes of defeat. So this is a sumo bot. It's probably one of the bigger ones. They have different classes. This is a medium class. Oh, that one was not very smart. It just got itself out of the ring.
I think I have visitor mode.
Okay, so right here, you can see that, and these are not remotely controlled. They're fully autonomous.
Oh wow.
These robots are fully autonomous, which means that they have several tasks to perform. They have to track the opponent, and also try to push the opponent out of the ring at the same time. Now they have different classes. They have a small class. I think they have even more now. They used to have a miniature, class. So those robots, the footprint has to fit, the size of basically my palm, okay, and that's the size of the robot, the footprint of the robot. These are medium sized, and they have even bigger ones. And now I think they have a micro class or nano class, so they're even smaller because technology has gone to the point where you can put robots together, even smaller and keep the same type of intelligence. So they have these robots. This is very popular in Japan. From the name you can probably guess, it originated from Japan. And high school students or even middle school students in Japan would put in their entries, into their own, sumo wrestling or sumo bot wrestling matches. The Japanese robots, in order to increase traction, which is friction, which depends on how much downward force you can exert on the robot. Each class has an upper limit in terms of weight, so you cannot just keep adding lead pieces to make your robot extra heavy. And that really doesn't help in terms of acceleration, because when your robot is really massive, it also moves very slowly. It cannot respond quickly. In other words, if you're charging at the opponent, but the opponent is lightning fast, it can evade you and then turn around and push you out of the ring too. So what the Japanese robots are doing is they have a suction, like a fan at the bottom of the robot that creates a suction, kind of like a Roomba, combined with a sumo wrestler, right? So you basically look at this like a sumo wrestler with two vacuum cleaners, right? Or a vacuum cleaner attached to the body to basically keep the suction up, so you can basically stay with a lot of friction or traction on the ground. But at the same time, you're not increasing the actual mass of the robot. So they have these robots to the point where they can wrestle upside down. The suction is more than enough to keep the robot upside down, and they can keep wrestling on a plate upside down. So this is something you can look into. I think some of you may be interested in this sort of thing. They're not expensive. The entry cost is about 40 to 50 bucks, and you can easily set up a ring with your friend. All you have to do is to go to Home Depot or some hardware store, buy the pre-cut circular wood board for tables and stuff like that, paint it black, and put a white stripe on the edges, so that your robot can use optical sensors to find out whether it's already at the edge or which side is already at the edge, so you can plan things accordingly. So you can have matches with your friend, each person spending $50, $60 or so, and in the end, it really boils down to the software. Okay, how well can you track your opponent, and how can you utilize the existing hardware on these robots. There's a robot club, in Sacramento. So, how many people know there's a Sacramento robotics club? Just look it up on Google, and if you are interested in robotics, they have people who work for Schilling in Davis, which is an underwater robot company. So they have a lot of people with a lot of expertise in robotics in that club. I used to be in that club, but since they always meet on Thursdays, in the evening, and I always teach on that day, I never was able to make it anymore. All right, so that's I think that's interesting. The other interesting thing is several people, not only one, but several people ask me, after this class, what classes should they take? It all depends on what do you think you want to do after you graduate, okay? Or what do you want to be your major when you transfer to a 4-year university. How many people already know, yeah, I kind of know what I want to do, after this class or after spending 2 years here? Okay? So most people do. How about the rest of you? I find that people who are, who cannot make up their mind usually are really good at everything, so that's why it's hard to pick out, a particular subject area. It was easy for me to pick out, computer science because that's the only thing that I was good at. So it's like, okay, I think I know what I want to do because there's only one thing that I'm really, relatively speaking, good at. Everything else really sucks. So the next class, if you like computer science and stuff like that, I'm just going to write it on the whiteboard. And I'm not doing the job of a counselor, so you still want to talk to a counselor to confirm this stuff. The next class you want to take, if you want to go through the computer science degree, which allows you to transfer after you complete the computer science degree here to a lot of the CSUs and the UCs. We have articulation agreement with individual campuses. So just because you can transfer all of these classes to, let's say, UC Davis, doesn't mean that you can transfer all of the same classes to UC Berkeley. So you need to look up, the transfer agreement between colleges and universities to make sure. So the next class is cisp310, which focuses on just the concepts of programming. If you like Scratch programming, in this class, and you think, oh, this is something that I really like to do and I want to pursue that, this is the next class. From CISP 300, you can go to CISP 360. So I'm only listing classes that you need to graduate with your computer science degrees. There are many other classes you can take. From 360, there are multiple directions from here. CISP 310 is assembly language programming. CISP 400 is object-oriented programming. And then from this one, I think it branches out to 2. We have CISP 430, which is data structure. And then we have CISP 440, which is discrete structure. This class is where you will need a lot of math, and not so much programming, but mostly math classes. So in terms of computer science classes, this is the kind of what I call the dependency list to show you, which class you have to take first, and then from that class, which other classes you can take. Any questions about this? Yep.
I'm just wondering, do you think UC Davis is a good school for good programs in computer science?
You really have to look it up, on, does anyone know what resources you can use to kind of look up the ranking of universities in particular programs? You can probably just Google it. I think you can Google and find out,
It's okay. Which school did you go to?
I went to UC Davis for graduate school. I went to San Francisco State University for my undergrad, and I went to UC Davis for my graduate school. In terms of the quality of instruction, overall speaking, San Francisco State actually is better.
Really?
Yeah, it was better. Even though it has no research, to be done, and it's a really small computer science department, in terms of lecture quality and just people, teachers, trying to teach classes and be prepared and stuff like that, San Francisco State University was actually pretty good, and most of my professors are still teaching there. Yep.
I'm saying that's because of the location. It's really close to where most of the large technological companies are.
Yeah, but SFSU is not really well known for its
Yeah,
engineering or computer science
Stanford's actually
programs.
better for computer science.
Sac State?
Yeah. No, not no. I mean
San
Stanford.
Jose? Stanford?
Stanford.
Yeah, Stanford is, Stanford is interesting. It has undergraduate and graduate school. I would say the Stanford graduate school, in terms of computer science, is top notch. Okay, it's comparable to CMU, Carnegie Mellon University, and MIT, Massachusetts Institute of Technology. So those three are in the same tier. Every year, in terms of the ranking of computer science, it's always those three switching places. Berkeley is a distant fourth. So it's always CMU, Stanford, or MIT within the first three, and they shuffle places once in a while. And then Berkeley is always stuck at the fourth position. At least when I went to graduate school, that's the case. If you look up the Grand Challenge, where universities have to make their autonomous vehicles to navigate through deserts, roads, and whatnot, the top two entries are always CMU versus MIT. No, excuse me, I take it back. It's CMU versus Stanford. The Google cars, the cars, the Priuses, or the Prii with the 360 camera and fully autonomous. That's actually a byproduct of Urban Challenge. And I think Google got a lot of the technologies from Stanford out of that project. So that kind of tells you about the research orientation of Stanford. It's not just theoretical, it's also very practical at the same time. But for undergraduate, I'm not sure how Stanford ranks compared to, say, Berkeley and many other schools. San Jose State cannot be bad because it's right at the center of the Silicon Valley. And it's also a CSU, which means you don't have to pay a lot of money for for registration and stuff. There's also San Luis Obispo, Poly. It's Cal Poly. Okay, yeah, Cal Poly is also another strong entry, very strong in engineering and and also computer science too.
Hard to get in them.
It's hard to get in, but once you get in, it's very nice because it's only about 30 minutes away from the Big Sur. Yeah, so it's very nice. The coast of California over there is very nice. And let me see how many people also know this tool. If you want to find out which classes can transfer. Now, when we talk about classes transfer, you have to be sure whether you're only transferring the units or whether you're transferring the classes so that you don't have to take the same class at a CSU or UC. So there are two types of transferring. Assist.org will easily tell you which type of transfer or what are the transfer agreements between campuses. So you have already chosen a major. So you have several ways to look up. We'll just look up ARC here, and here we can select if you want to transfer from ARC to one of the universities on this list, it will tell you exactly what classes can transfer to which other class at the other university. So let's say we're talking about San Jose State, CSU San Jose State, right here. Okay, I'm just picking this as an example, and we'll pick computer science as a major. Oh, just click quickly. Okay, so we go to computer science bachelor's degree, and here's the transfer agreement. So from here, if you take Math 30, it's equivalent to Math 400 over there. Or is it the other way around? It's the other way around. So Math 30 over there is Math 400 here. Math 30P is, we don't have any equivalents. So you just kind of scroll the list down to, we have physics and biology, and then we have computer science classes. So our 300 does not transfer because our 300 is really a pre-programming class so that people feel more comfortable in CISP 360. At San Jose State, they start with that class. So right now we don't have any agreement from CISP 360 to their CS49C, which is something that we probably have to address because that means when you take CISP 360 here and you transfer to San Jose State University, you might have to take CS49C again, even though the higher level classes do transfer, which doesn't make a whole lot of sense. A lot of times, if it doesn't transfer according to the agreement, you can still petition. Go to San Jose State, explain that I would like our CISP 360 to transfer to your CS49C. Most of the time, if you present the curriculum, the syllabus, and stuff like that, and also the work that you have done in the class that you take here, many times they will make they will just approve your petition to also let you transfer your CISP 360. So don't give up if it doesn't show on the list. Go ahead.
So in order to take 310 and 400, you have to take 360, right?
Yes.
If you take 360 here,
Mm-hmm.
it's the same class over there.
It doesn't.
Retake it like over there. Is that what you're saying?
According to this list, if they stick with the rules, you will have to retake CS49C when you get over there. However, it doesn't make a whole lot of sense. So that means it's just a matter of getting the agreement done. So if it doesn't show that it transfers here, or if it says no current articulation, what you want to do is to approach the professors over there and ask them how you can petition for the units and for the class to be considered equivalent. Many times, if you supply enough evidence, like your homework, the syllabus from CISP 360. You can ask your professor here to give you the curriculum. A lot of times, if you supply enough information, if they take a look and go like, oh, okay, it's really about the same as how we teach it over here, and they will just approve your petition, and it will let you count CISP 360 as 49C over there. But that's an individual process. You have to do it yourself, and they always have the right to say, no, you have to take the class again over here. But it's worth trying. Okay, it doesn't hurt to try. Okay. Are there any questions? So they have, there are other classes too, the electives. This one we have no current articulation, Unix and Unix utilities. So you have to look up their list and see if there are any classes here that may come close, and then you can take the class that comes close here. And especially if you can get an agreement over there first and say, okay, if I petition to have this class considered equivalent to your other class, if you get an agreement beforehand, take the class over here. So when you transfer, you have most of the classes already done, except for the upper division classes. All right. Any questions?
Yeah, like in the beginning you were saying that you need to make sure if you're transferring classes or versus units. I didn't quite understand what you meant.
Some of our classes here, like CISP 300, the units may transfer. In other words, it may fulfill some of the GE requirements over there, so you don't have to take. It just fills up the unit bucket, but it doesn't fulfill their requirements to graduate with the particular program that you're into. Okay, so you can fill the unit bucket all you want, but if it is not equivalent to their CIS, CS, 49C, that means you still have to take that class in order to get a bachelor's degree over there. Okay. For more details, talk to your counselor. Okay, it's their job to give you, all this information. But I think, having this, picture here can really help you schedule your classes, because this really tells you that, from the semester that you take CISP 300, you still need 1, 2, 3, 4 semesters to get through the entire thing. And that's assuming you can get into all the classes that you want the first time. Yep.
You can also go with 370 instead of 300 if you want.
Into 360, yes. So there's an alternate path to it.
370, yeah, instead of 300 like to start with.
Yep.
But it's prerequisite in order to take 360.
Yep. That's the alternate path. Yep. Very good. 370 is Visual Basic. So if you want to learn how to program in Visual Basic, you might want to take 370 instead of 300. Any questions about this picture or assist.org? How many people knew about assist.org before I talked about it? Okay, I would say that's about maybe 1/5 of the class. So now the entire class knows about assist.org. It's not just for computer science. They have articulation agreement across a lot of different programs. So if you just go through this list here, it goes everything from anthropology all the way down to theater arts. So a really big spectrum, full variety. Yep.
Just one question.
Yep.
I took 370, I didn't take 300. Do you think I still need to take 300?
To get to 360, CISP 360 here. If you feel comfortable in CISP 370, like you can do all the homework assignments, you feel comfortable with the concepts, and everything like that, then you probably will be okay in 360. If someone, is barely passing 370 and is kind of saying, well, I'm kind of shaky in terms of these concepts, what is a subroutine, what is an array, how do I work with an array, stuff like that, I would suggest that person to retake, take CISP 300 first. But if you already feel comfortable with all the concepts from CISP 370, you can just go to 360. All right. So any other questions? No other questions? Have I ever shown to you guys this website too? I think I did, but I will show it again. BLS, U.S. Bureau of Labor Statistics. Have I shown you this website? Maybe a long time ago? No? Okay. You don't remember? All right. So let's go ahead and take a look at this list here. Because I think, a lot of times, people don't know what they want to do because they don't know what options there are, in terms of careers and occupation. So we'll go ahead and take a look at employment, job opening. We're looking for Outlook, job Outlook. Do this search here. Oh no, I broke their website. This can be handy even if you know that you're on the computer science track. It can still be handy because even within the computer science area, there are still a lot of different alternatives, ways you can specialize. And you can also double check that the kind of job that you want to do, still has a lot of opportunities when you graduate. So here we have a really brief summary of all the different occupations, and I'll just kind of zoom in a little bit. Over here, it shows you, the occupation, the title, job summary, entry level education, as well as the median pay in 2010. So the first one is computer and information research scientists. Typically, we just call those, computer scientists. These people are the ones who would research, invent, and design new stuff. For instance, remember what we just talked about, using the $500 hardware and turn it into a basically, it's a UAV, but it's a self-controlled UAV. It's autonomous. Okay, that would kind of fall into this category. Okay, because you're doing things that very few or no one has done before. So that's basically a research type of topic. The median pay is about $100,000. But in order to get this kind of job, you need to have a doctorate degree, like a PhD, or professional degree, some other professional degree. That takes up extra time. That's 5 years. Okay, that's 5 years in graduate school. So when you ask me, if someone asks me, is it worth it or not? It's a toss-up. I can only tell you it's kind of like a toss-up because some people, if they spend 5 years in Silicon Valley, they can climb up, high enough to compensate for the pay difference, for the entry-level pay difference. Because in Silicon Valley, a lot of times, it's what you know and what you can do and what you can demonstrate that is important. It's not as much what kind of degree you get from which school. Okay, so they're very bottom line driven. The next kind of job, and also, if you click on the link, I'm going to open a new tab. When you open this up, it will tell you a lot more information. For instance, they will tell you the median pay, which we know already, entry-level education, we know that already, number of jobs in 2010, only 28,200, which is not a whole lot. This is across the entire United States. Job outlook is what you need to look into, is how fast is this particular type of job increasing in terms of employment opportunity. So it's increasing by, or projected, the projected increase from 2010 to 2020 is 20%, which is about average. Okay, I wouldn't say this is like, really superb. Are there any questions about this? Okay, if there are no questions about this, we can look into another one. Computer programmers. Computer programmers write code to create software program. They turn the program designs created by software developers and engineers into instructions that a computer can follow. So in this case, you're basically the contractor in our house analogy. Remember when we talked about building a house, compared to building an information system? This is the job of a contractor, okay? And you can tell that the pay is a little bit less. You only need a bachelor's degree. The pay is $71,000 and so. But when you look into it, it is kind of alarming. It makes you think about, is that really what I want to do? Because when you look into the details and you look at the job outlook, it's only 12%. And, it will also tell you, down the list a little bit, this kind of job is also easier to outsource to overseas, or have people to come in with an H-1B visa to do this type of job. So that means, even though the growth is about as fast as average, in terms of job security, it's not as good as a computer scientist, because the jobs can be outsourced a lot. All right. So the next one would be computer support specialist. Well, we kind of know what a computer support specialist is. Support specialists provide help and advice to people and organizations using computer software and equipment. Some called tech support specialists support information technology employees within the organization. Others called help desk technicians assist non-IT users who are having computer problems. For instance, if you're using D2L and you're having problems, getting into D2L or figuring out how to turn in a homework assignment, the help desk of D2L or IT in general falls into this category. There's not a whole lot of requirement. Some college and usually no degree is required. The problem with this type of job is it's already mostly outsourced. Okay, it's already mostly outsourced to other countries because it really does not require that much expertise. So when you click it, you'll see more details. It's probably not bad if you can find a job like this in the interim, when you are still going through school, you can use this to pay your fees through school. But in terms of long-term employment and also your career plan, this may not be a very good idea, because it is only showing you the growth, but it's not showing you, how much of this can be outsourced or are already outsourced. All right, so let's go through this list. Computer systems analyst or systems analyst. Remember, we talked about a systems analyst being the architect and also the engineer when you build an information system. And that's what it is. The base pay is only $77,000, but the range is actually very wide when you become a systems analyst, because it depends on the industry that you work with. If you work with, let's say the supermarket industry, okay, the base pay may be about the same as $77,000. When you work for Wall Street companies, your base pay can bump all the way up to, let's say, $150,000, because it depends on how much money you can help the organization make, or alternatively, if they lose you as an employee, how much money or what is the cost of having to replace you as a systems analyst. So a lot of that depends on how well you know about the industry that you are already in. So if you have a finance, a minor degree in finance, and you become a systems analyst for a bank, I think your base salary can be negotiated to be quite a bit higher, because not only do you understand information systems, programming, and all the technology things, but you also understand how a bank works. All the finance terms, everything that a bank does, you already understand. So you have the expertise in the subject, in the organization itself, as well as the technical knowledge of how a computer system works. So that will basically give you more negotiation room when it comes to negotiating your salary. It also makes you more competitive as a potential employee, because the employer says, if I hire just a systems analyst who knows nothing about the finance, the part of a bank, then that person has to be retrained a lot to understand, this is, this term means this term means this, and this term means this. But if you already have a minor or double major in finance, all that stuff is done already. You are already an expert in that particular area, and they don't have to retrain you for that sort of thing. We have database administrators, who basically specialize in dealing with databases. We have information security analyst, and this one is also interesting. This and also this is really just for the entry level. It can go all the way up, because in terms of computer security, the cost of having a breach is becoming so expensive that a lot of organizations are willing to pay more money for better expertise to help the organization prevent security breaches and stuff like that. Network administrator, fairly kind of traditional thing. It cannot be outsourced if it is physical. In other words, if you have to go do all the wiring for an organization. But we also have a flood of people with this type of expertise too. And then you have software developers, and this is not a bad number, $90,000, and it only requires a bachelor's degree, because this is really bottom line driven. Can you do the job or not? Okay. So these are the creative minds behind computer programs. So they're not really exactly just the contractors, but they also have to be kind of more inventive. They're somewhere between a systems analyst and a programmer, because the systems analyst would just say, okay, we need to put cabinets of this size in the kitchen, and then the contractor says, tell me exactly what you want to build, and I'll build it. These people are saying, okay, how can we make the cabinet of this size and make the best use of the space and make it user-friendly at the same time? Maybe we can put a carousel into it to make it rotate. Maybe we can use some really interesting material, make it translucent, so not only can you store dishes in it, it can also be a source of light at night and stuff like that. So that would be the job of a software developer, or otherwise known as a software engineer. So when you look at this, I think this one has the highest growth in terms of job opportunities. Last time I checked. 30%, much faster than average. And this is also the kind of job that is more difficult to outsource, because anything that requires creativity is more difficult to outsource. It has to do with the education system of different countries and also different cultures. A lot of cultures who specialize in science and math and stuff like that, the education structure is more rigid. So people are less creative for the most part. I cannot say across the board, but overall speaking, they're less creative. In the United States, because of the variety of universities and also the type of researchers we have, and also the professors we have in these high-end universities, people are typically more creative. They just explore things and think out of the box more. I really don't like the term thinking out of a box, because we all think in a box. It's just that some people have a bigger box. So think that way, how big is the box? We're still thinking within a box. Even Einstein is still thinking inside a box.
He just had a pretty big one.
He just has a very big box, yes. But even that box has a limit, it's finite, because even Einstein, says, quantum physics is, hocus pocus, right? And he's the guy who says, time and space can bend and all kinds of stuff like that, which is really, a pioneer, to think that way. But he just could not accept, the premise of quantum physics that everything is just probabilistic and not definite. He's still thinking in a rigid way and say that, oh, things are just rigid. If an atom is here, it is here. If a subatomic a particle is here, it is here. Where quantum physics says, nope, we don't really have, an electron, orbiting, a nucleus like this. It is just appearing here, and then it appears here, and it reappears here, without going in between, the appearance of the electron.
Interesting concept.
It's interesting, and it works out, with actual, data, and it's a good way to explain a lot of things. But Einstein just could not accept it.
Yeah.
Yep. All right. So are there any questions about this website? I think this is a useful website. Just from time to time, they update the information too. So all this projection here, they update all this information from time to time. So by the time you get to a 4-year university in 2 or 3 years, these numbers would change. So you need to kind of keep your mind open and say, well, I need to check on this again, from time to time and see, how these numbers are changing. What about people working in Google? Which category do you think they fall into? Let's say the people who made Gmail the way it is.
Information systems analysis.
I would say Gmail falls into this category. Software developer. The concept of email is very old. That's nothing new. The concept of using a web interface email is also really old. But to make it really smooth, user-friendly, and be able to do more than just email takes a software developer, not a programmer, but a software developer or software engineer, which is the other title for this type of people. Okay, what about people who work at Pixar? People who are behind all the special effects of Toy Story and all the other movies. I would say some are in this category, but many will fall into this category. Because rendering a lot of the special effects in a movie, for instance, the effect of fog, water, flame, and stuff like that, those are things that we have not done before. It's not something that we are just refining. It is actual research on the fly. You're doing research on the fly. When a movie calls for a particular special effect, they put a team on that special effect and say, okay, how can we make this realistic, or how can we make this more stunning, in terms of special effects, and that really falls into that category. I know people who work at Pixar with PhDs. And and Pixar allows a lot of flexibility when it comes to how people work in that organization. Most people know about the 25%, is it 20 or 25% at Google that you can actually quote unquote pick up a project on your own. Okay, it's not really quite that simple, but nonetheless, they do give you some room to explore projects on your own. At Pixar, it's about the same because the movie industry has a very definite cycle. They only release major movies at a certain time, like around the summer. So that means right from summer to winter, that half year there's really not a whole lot of demand because the next movie is not quite done yet. They're still thinking about the next movie, and a lot of the people who work for Pixar, they can pick up pet projects, so to speak. So someone can say, well, I really want to see how we can make soft drink, the bubbling of the soft drink realistic. Okay, how many of you have looked at how the bubbles form when in a glass of soft drink like 7-Up or Sprite? Okay, it starts from nowhere, right? It starts from basically nowhere, and then the bubble gets larger and larger because the water pressure is getting smaller and smaller, and therefore the bubble can expand. Well, someone at Pixar can say, well, that's what I want to do. I want to research, how to make, the bubbling of soft drink more realistic. And that's what they do for about half a year. So, that's the type of, creativity or creative nature type of job, even in computer science. What about gaming? I know a lot of you like to play computer games. How many people want to become a part of the gaming industry? Okay, you can raise your hand. I mean, there's nothing wrong with that. The game industry is now bigger than the movie industry. I think I said it several times already in this class. So in the gaming industry, they need people like this type too, because I just talked about special effects, and that's that's a lot. That's very research oriented. They also need computer artists and also computer people who make special effects easier to make. If you really just think about computer animation, you think about it and go like, yeah, it's just the computer drawing a picture. How hard can that be, right? What do you think? You can just download a program called Blender, which is a 3D rendering program, and have at it, right? I mean, is that really just that, or do you think it's a little bit more complicated? It's a lot more complicated. Okay, if you just use Blender, and make your computer animation, what do you think you can do with facial expression of the people that you create?
Make it very broad.
I can draw a picture. Right? Now, next, how do you make this a realistic person? In other words, the facial expression. How do you make that realistic? What do you need to do to make this more realistic so it can express the same type of emotion that a person can? Now, the facial muscles, and the cheapest way to do it is to do what they call modeling. In other words, you put like little dots, little stickers on somebody's face, and you have a specialized, a system of cameras to look at that person as that person, smiles, frown, cry, and stuff like that. You're basically digitizing how the shape of the face changes, for different types of expressions. So once you understand the system, how the dots are correlated, when someone smiles or frowns and stuff like that, then you can actually use that model and apply that to a computer-generated character. Okay. So that seems to be pretty easy, right? But what if you're trying to model is not a person? How many people have watched How to Train a Dragon? And how many people actually spend the time to watch all the other stuff on the DVD? Several times. Okay, so they are making a dragon. I think the type is called a Nightcrawler, if I remember correctly. And my kids can correct me, if I get it wrong. But they're trying to make the dragon. You just have to watch the commentary from the producers and whatnot. They're trying to make the dragon realistic, but if there is a dragon, right? But they're trying to make it more walk like a lizard, okay? Because lizards walk in a certain way, not like a horse, right? But at the same time, they want to make it cute and yet kind of scary at the same time. So they have these expressions on the dragon that is not typical of a person. It also has cat-like behavior too. Like when it bounces from one place to another place, it almost behaves kind of like a cat, and the way it wiggles its tail is almost like a cat too. So all of that stuff requires programming. Okay, because when you think about your movement, like just moving your hand and stuff like that, what is the structure of a person? I mean, your hand. Okay, if you think about a person. Your hand is not really a rubber band. You cannot do it like this, right? You have joints, and the joints have limits too because of the tendon and the system of muscles. So if you want to make a computer character realistic, you also need a system to model all that stuff, the bones, the bone structure, muscle structure, the tendons, and all kinds of stuff like that, so that your character would not try to bend its arm like completely backwards, which is impossible for a person to do. So all that stuff also requires programming. If you have to program, okay, think about your fingers. Okay, how many joints do you have in your hand with just your fingers? A lot, right? So if you think about computer animation, if for each frame of the movie, for each character, for each finger, you have to reprogram and specify how it moves. How much time do you think you have to spend to just do that? Several years at least. Okay, so that's not how they do things. What do you think they do when they say, okay, I want this character to grab an object? Okay, so the grabbing motion, what do you think they do would be a reasonable thing to do for a movie maker like Pixar? They have special programs to do it. Okay, they have special programs to model the muscles, the bones and stuff like that. So what you're really specifying is to do the grip motion. And the grip motion thing is applicable to all the different characters. They may have big hands, small hands, skinny hands, and whatnot, but the modeling of the gripping motion is the same. So this is the kind of things that we are talking about that requires a lot of research, because it is not something that is already done. It's not just details. It is how do you make computers work better to do things that was difficult to do before. Okay. People who like gaming can also tell me about this. When you do your games, especially with the multiplayer capable games, do you prefer to play with the computer characters, or do you prefer to play with other online players? Online players. Why?
Sucks. AI usually sucks.
Because the AI usually sucks. Now, how does it suck? Is it too smart for you?
Limited.
Exactly. They're usually very limited. When you play against people, they can respond to your strategies, right? Okay. If they are your allies, they know. Okay, if you're doing this, I'll be doing something else to achieve a common objective. If they are adversaries, they can adapt to your strategies and go, okay, I know your pattern. I know you're gonna snipe me from this location. So next time, I'll either avoid it or I know where to look for you, right? But the computer AI usually doesn't do that. So if you want to make a game more successful and sell more, well, that's one of the things you can do, is to improve the AI engine, so the computer can actually learn from getting defeated and actually respond to your strategies so that the game is more intriguing and you can play a little more. Kind of like Moriarty in Star Trek: The Next Generation. Go ahead.
Another problem that they have with the AI right now is they're trying to make it more realistic to be human, right? Right now, another problem they have is that they're too hard in some cases because they have just super aim.
Super
Super aim.
It's hard to get that human.
Oh, you mean like a slow-mo?
Well,
No,
basically
like-
aim body,
They always get their target if they're able to pull off the trigger.
even when they
before
can't see you.
Yeah.
Oh, the computer, the AI
Yeah.
can cheat, basically.
Get you with a submachine gun from all the way across the map. That's pretty bad.
Basically, they have bots. They have bots that have superhuman power, and it's hard to defeat. So it's not realistic. The bottom line is not realistic. It's either too simple, too dumb, or it's too smart or too capable. It makes it look unrealistic. Go ahead. No. It's the same point. Okay. So how do you make a computer game, as realistic as playing with another player? That's a really hard problem. Okay. To to understand, that type of problems, you can look up a Turing test. The Turing test is a test derived derived by Alan Turing, which is considered the father of computer science. So basically, everything that we do today with computer science is basically something that this guy already thought of in the 50s, in the late 40s and the early 50s. The Turing test, has a variety. It's basically how you can use a computer to how a computer can convince another person, either wirelessly or remotely, that it is not a computer, that it is a person. It's about a computer impersonating an actual person so that somebody else cannot tell, yeah, I'm talking to a computer, right? It's easy for a person to fail Turing test. Some people with like certain type of mental disorder can easily convince the other side that they're not talking to a person. It's much harder for a computer to pass the test. It's easy for a person to fail the test, but it's hard for a computer to pass the test. So when we're talking about AI in gaming, it's the same thing. Okay, when you play a game, can you tell whether you're playing against another online player, or can you tell you're playing against the AI of the game? And what you're telling me is very easy to tell, because the AI is usually very dumb and it's doing the same thing every single time, the same pattern, the same way, or it's super capable. It's sniping you across the room with a little 22, right? Slingshot.
Yeah.
Yep, because it can compute a trajectory and everything in an instant, and that's why it can do it. Yep. So that's why the Turing test, in a way, is related to computer science and also gaming, which I'm pretty sure Mr. Turing never thought about, because he was only talking about conversations and text type of communication, but in gaming it's a lot more than just text communication. Is there any text communication in gaming? Of course there is. It's full multimedia communication, right? You can text. You can also use a headset, so you can actually talk through the headset with another team member, which adds another level of difficulty when it comes to the AI, because now it also has to understand what you're talking about and be able to respond to it if you want the game to be realistic. So lots and lots of possibilities in terms of employment and potential use of computers that we cannot quite do today. Okay. Any other questions, comments? Yep.
Have you ever programmed, like program or video game?
I have never programmed video games per se, except for Scratch. My kid, he is actually writing a lot of games, with a Scratch engine. Very simple game, but I'm still kind of surprised that an 8-year-old was able to write the game that he actually writes with only reading some of the other programs, superficially. So he's downloading programs from other people and studying how they do the scrolling effect and the falling effect and stuff like that. But in terms of actual games, no, I have not.
Programs.
Programming in general. My previous job, that I held for 8 years, was a embedded system developer. So I was in charge of everything. I took on many roles at the same time. A lot of these roles, a lot of these occupations, I basically wore different hats in that job. So there's a lot of programming, but I did a lot of low-level programming, using assembly language, and that's why, I was hired to teach, assembly programming here. That was my original assignment, is to teach assembly language programming over here. That really takes another type of programming. When you're programming hardware, there's one big difference. Let's say you're debugging your Scratch program. How do you know that your Scratch program is not doing something right? How do you detect the problem, and how do you fix it?
Test it.
You can test it, and when you're testing it, can you see the internal state of the program? In other words, can you tell the values of the variables? Yeah, I mean, you just need to check a check mark, in Scratch, and it can display the content or the values of the variables on the screen. So all you need is to stop the sprite at a certain point, take a look at the values of the variable at that point, and then from there you can probably deduce, why your program is not working. In some form of embedded system programming, which relates to sumo wrestling, right? Because if you want to program the brain of a sumo wrestler robot, how do you know your program is not working? It's running out of the ring by itself, right? Okay, but how do you know why it is doing it? Now it's a different story. Because it's not as easy to debug a program when it's running remotely on a robot. Okay, and back when I was an embedded system developer, they didn't have the Bluetooth technology that we have today. They didn't have the Wi-Fi technology that we have today. They did not have the compiler or debugger technology that we have today. Many times, the only way I can debug a program was an LED. Is it blinking? Is it lit? Or is it off? That's the only clue I have, as to what my program is doing or why it is not doing what it's supposed to be doing. So it takes, a different type of, programming mindset, in that kind of occupation. Most of you do not have to deal with that sort of problem anymore. Any other questions about computer and information technology occupations? How many people in this class are on a completely different track, not related to computers whatsoever? I apologize for wasting your time. How many people are thinking about switching? No? Okay. If you're not in computer science, do you mind if you telling me which area you're interested in? Sorry?
Economics.
Economics? Okay. That's a very interesting field, but there's still a lot of applications or a lot of possibilities to use computer applications. Because economics, uses a lot of modeling, and computers are very useful when it comes to modeling. In terms of it can analyze past data, and if you have the right model and the right system to do it, you can use that to kind of help predict, how the future will be when it comes to economics and also finance. And that's why Wall Street has been sucking up a lot of engineers. Wall Street meaning all those big investment firms and stuff like that. They actually go to engineering classes and advertise their openings because they need smart people to work with those companies because they want to be able to help project how the stock market will move around and how to detect problems and how to make more money out of their systems. So they're hiring a lot of the smart people who otherwise would be in engineering. But they got all those people to work in the finance field instead. Okay, any other questions? No other questions? All right. Let's see, we still have a little bit of time left.
About the project, you said you were going to
You're going to go over the presentation project? You're going to go over the presentation project?
The presentation.
And also, I remember we were talking before about you might do like a quiz, extra credit or something.
I'm going to make the presentation extra credit.
Not presentation, but something else besides it.
Oh, well, if I give you something else, then it won't be extra credit because the presentation itself is extra credit. So.
Oh, the presentation is extra credit?
Yep. I think that's what I said last time.
Oh, you did? Oh, I missed it. Sorry.
You missed it? Yep.
We were talking about it.
I have several emails from people, basically proposing different things for the final presentation. And I think everything is okay except for anything that's offensive. And I think the biggest problem that some people might have is they cannot decide on the actual topic. You only have 3 to 4 minutes, which is not a whole lot of time. So if you pick something that is really general, you may not have enough time to cover the entire thing, because you have to do the introduction first, why people may be interested in this topic, this is what I'm talking about, and present the actual content of the presentation, and then the closing. So 3 minutes is really not a lot of time. So are there any general concern about the topic that you might want to do? Because if you have any questions, you might want to kind of talk to me in person. Doing it by email is a little bit difficult, because sometimes if your topic choice is too broad, then I cannot know, okay, but which specific area are you interested in, or do you want to talk about? Anything that you think most people are interested but not know much about would be kind of suitable for this class, for the presentation, as long as it is related to one of the things that we talk about in this class.
So like a topic like privacy, it'd be better to stick with something like more specific, like identity theft.
Yeah, I think something more specific is better than something that's more general. If you talk about identity theft, you might want to talk about a specific type of identity theft, like what it is, how it's done, and how to prevent it. So in other words, you want people in this class, your peers, not to only know about it, but walk away with something that is useful. Okay, so that would be best if you can arrange that part. Any other questions about the presentation? I have not decided yet.
On the website, you would make a grade instead out of 100 on the presentation software. I'm assuming that's not right.
Yeah, I can adjust. I have to adjust the weight of it. Yep, maybe half the weight of an exam, so about 10% of your final grade, which is a lot. Yep.
Have you decided whether or not the final is going to be just one big scratch project?
No, it's not going to be one big scratch project. It will have a scratch component, but it will also have kind of the same component as the first exam. So there will be some kind of mundane, multiple choice and questions and like that. It's open book, open web. So you can use Google. I was trying to see if I can arrange this class to use the computer lab, so we can all go to the computer lab and take the test. Yep.
Is it going to be all multiple choice questions? That way we don't have the problems with.
I will take out all the short answers, so there won't be any issues with typos, misspelling, plural versus singular, and that sort of thing. So that would be helpful.
Yeah.
To me.
Around how many questions?
Around how many questions? I would say, in terms of number of questions per minute, it will be about the same as the first exam. So there will still be a lot of questions. But on top of that, there will be like a scratch component to it too. So I might break it up into 2 parts, where the time allocation for the first part is one set, and then there's another time allocation for scratch. Or do you guys want to do your own scheduling? Just give you one big block of time, and you can schedule it any time. No? One big block of time?
Yeah.
Okay.
Oh, wait, we can do it whenever? And we can do it whenever, is that what you're saying?
Yeah.
Oh, yeah, I like that.
You like that better? Okay. That's fine.
What do we have?
Yep. Only the chapters that we have done homework on. Just those. Yeah. So we have only done like 2, 3, 4, and then 10. I think.
Oh, so it's gonna include first four.
Yes, it's comprehensive. It's comprehensive, but only limited to the multiple choice and short answers that we have already seen. It may come from it's coming from a pool, so it may still have questions that you have not seen before, because it's coming from a pool. But it will be the same type on the same type of topic. So it's still open book and open notes, so you can bring your textbook and whatnot with you. Any other questions?
Yeah, sorry. Didn't you say you have another homework for the final exam?
Do you want another homework?
Yeah. No.
Okay.
If you're going to do it, just prefer it to be scratch.
I'll think about it. Okay, I'll think about it. I have been thinking about it for a while, because I want to somehow integrate, Scratch with systems analysis, because you can use Scratch to design a user interface, pretty easily. So with or without user interaction, it's actually doable. You can use it to make a dial and buttons and stuff like that. So that kind of relates to systems and analysis. So I was thinking about doing it, but I could not come up with an actual idea of what you can do. So I'm still thinking. All right. So we are running out of time today. I'll see you guys next Tuesday. Have a nice weekend.
Thank you.